Hey everyone, welcome to another video. Today we're going to be building on what we did in my previous video. Before we were determining key features of rational graphs, and today we're actually going to be graphing them. So the first thing we do when we encounter any rational function is try to factor the numerator and the denominator. So our numerator is x squared minus 3x minus 4, and that factors to x minus 4 and x plus 1. X minus 4 and x plus 1. Now our denominator is x squared minus 6x plus 8, which factors to x minus 4 and x minus 2. Okay, x minus 4, x minus 2. Now, when we look at the numerator and the denominator, we notice that both of them have a common factor of x minus 4, which means we can feel free to cancel out x minus 4 from f of x. And that's actually where our whole is going to be in our graph. So, but for now, let's just write the final version of f of x, which is going to be x plus 1 over x minus 2. Now, as you can see, we canceled out x minus 4. That means that at x equals 4, our graph is going to have a whole. So let's plug in 4 into our final version of f of x in order to get the y coordinate for our whole. So f of 4 will equal to 5 over 2. Okay, great. So we have identified one of the key features, so we can just circle this and leave this for whenever we're going to actually start graphing. Now, I want you guys to look at this final form of f of x, right? Our denominator is x minus 2. That means that at x equals 2, we're going to have a vertical asymptote. So vertical asymptote will be at x equals 2. Now, if you look at this graph, you'll also see that the degree of the numerator is the same as the degree of the denominator. That means our graph is going to have a horizontal asymptote. And to determine the asymptote, we'll have to look at the leading coefficients of the numerator and the denominator. Since the degrees are the same, the horizontal asymptote is the leading coefficient of the numerator divided by the leading coefficient of the denominator. So the horizontal asymptote is y equals leading coefficient of the numerator divided by the leading coefficient of the denominator. Now, the leading coefficient of the numerator is 1, and the leading coefficient of the denominator is also 1. So our horizontal asymptote is just y is equal to 1. Now, let's take another color. And if you guys are doing this on paper, you can also take another color, like use another colored pencil. And let's draw our asymptotes. So let's draw our vertical asymptote at x equals 2. We'll use a dotted line to distinguish. Great. And now our horizontal asymptote is y equals 1. So we're just going to make another dotted line around here. I'm sorry, I know this graph isn't perfect, but it is what it is. Okay, so the vertical and the horizontal asymptote are the lines which the graph is going to approach but never actually touch. So now, when we have our asymptotes, we should pick 3 points on the left and 3 points on the right of the vertical asymptote. So our vertical asymptote is x equals 2. Let's pick 3 points on the left of x equals 2. So we can pick 1, we can pick 0, and we can pick -1. So let's have it -1. -1, 0, and 1. Now 3 points on the right of x equals 2. We can pick 3, we can pick 4, and we can pick 5. Okay, so far so good. Now that we have all these beautiful points, we can use the calculator to plug in the x values into the final version of f of x. So if we plug in -1 for x, we're going to get 0 over -3, which is just 0. And if we plug in 0, we're going to get 1 over negative 2, so just negative 1 over 2, negative 1 half. And if we plug in 1, we're going to get 2 over negative 1, which is just negative 2. If we plug in 3, we're going to get 4 over 1, or just 4. Now, when we get to 4, things get interesting. Because if we noticed here, we have a hole at x equals 4, and the y-coordinate is 5 over 2. So we can write 5 over 2 for the y, but don't get confused, because this is actually a point in the graph. This is just a hole where we're going to draw, well, instead of a shaded circle, we're going to draw an open circle. Okay, and if we plug in 5, we're just going to have 6 over 3, which is just 2. So now let's plot these points. Let me get a different color. What color should I use? I think I'll use this kind of lighter screen. Okay, so let's get a bigger color, like 4.12. Okay, so all these points should now be plotted. Negative 1, comma 0, which is right here. Actually, wait. I think I can I use this? Okay, I think negative 1, comma 0. 0, negative 1 half, which is right here. 1, negative 2, which is right here. And then 3, comma 4. 1, 2, 3. 1, 2, 3, 4 is right here. And now at 4, comma 5 over 2, we are going to we're gonna have an open circle, right? So we can open circle. 4, 1, 2, 3, 4, and then 5 over 2 is right here. Okay. Okay, it's not perfect, but it doesn't have to be perfect. Okay. And then 5, comma 2. 1, 2, 3, 4, 5. 1, 2. Okay. Okay, great. So now that we have our points, we can just take a regular pencil again. And now we're going to connect these points and make sure that the arrows go towards the horizontal and vertical asymptotes, but never actually touch them. So let's use green again. Let me use a lighter mark. Okay, let's start from this one. It's going to go through all of these points. It's going to approach the horizontal asymptote, and then we can just finish off with an arrow. And then it's going to go down, approach the vertical asymptote, and just never touch it. It's going to keep getting closer and closer to it, but it's never going to touch it. And now for the top right quadrant, we do the same thing. Connect these points, skipping the hole. Notice how there's an open circle at the hole, because this isn't actually a real point that's on the graph. This is just a hole. See how it's going to approach all these asymptotes, but never actually touch them. And we did it, guys. This is our final graph. Let's zoom in for any of you guys who want to take a closer look. See, we have our holes, we have our points, we have our asymptotes. Now, guys, feel free to take some notes. Copy this down in your journal if you want to. I'll leave down an example in the comments so you guys can do one more. And feel free, tell me in the comments, tell me how it goes. Tell me if you have any recommendations on how you want me to explain stuff, if you would like more examples, and stuff like that. I hope I'll see you guys in the next video. Thank you for watching. Goodbye.